In this video, we are going to determine whether the following series converges or diverges. So here we have the sum from n equals 1 to infinity of 1 over n factorial. So we're probably going to want to use the ratio test because we'll get some cancellation if we write an plus 1 over an. So what do I mean by that? Well, first let's review what the ratio test tells us. So the ratio test tells me that suppose I have some series and I define a limit L in terms of part of that series. So if I'm summing the an, then L is going to be the limit as n approaches infinity of an plus 1 over an. Then if L is less than 1, then the series converges. If L is greater than 1, then series diverges. And lastly, if L equals 1, then the series may diverge or be conditionally convergent or absolutely convergent. So this is inconclusive. Now, in our case, an is 1 over n factorial, and an plus 1 is 1 over n plus 1 factorial. So an plus 1 over an is equal to 1 over n plus 1 factorial all over 1 over n factorial. This is equal to 1 over, now I'm going to rewrite n plus 1 factorial as n plus 1 times n factorial. The reason I can do this is because n plus 1 factorial is n plus 1 times n minus 1, and so on until we get to 1. And this part is essentially just n factorial. So I can rewrite this as n plus 1 times n factorial. Great. So I have 1 over n plus 1 times n factorial times the reciprocal of 1 over n factorial. So that's times n factorial over 1. So I see that I have some cancellation and that an plus 1 over an is just equal to, or maybe I'll write it under, this is equal to 1 over n plus 1. Now we want to define this limit L, which is the limit as n approaches infinity, the absolute value of an plus 1 over an. So this is 1 over n plus 1. And so as n approaches infinity, the denominator is growing very, very large. So this becomes 1 over infinity, or in other words, 0, which is less than 1. So the first criteria tells me that the series converges. If this video was helpful, please like and subscribe.